Let's solve the system of equations. What's really cool about this question is it comes from the December 1880 University of Cambridge entrance exam. Where did I find it? I found it on archive.org. It's a really awesome place. You should check it out. Well, here we have x plus 1 times y plus 2 equals 10, and x times y equals 3. What I'm going to do first is I'm going to solve this equation. Now, it doesn't matter if I solve for x or y, so let's solve for y this time. We always seem to solve for x. All right, now we're going to take this second equation, and I'm going to put 3 over x in for my y. 3 over x plus 2 equals 10. Now, let's FOIL. First, outside, inside, last. And let's see what we get. I'm going to write the first one out. We're going to take x times 3 over x. Then outside, plus x times 2. Inside, plus 1 times 3 over x. Plus last, which is 2. Now the first one is nice because the x's cancel out. So we're going to have 3 plus 2x plus 3 over x plus 2. And I forgot, this still equals 10. I want to get the x's on one side and everything else on the other side. So I'm first going to put like terms together. And I'm going to wait and worry about this 3 over x here in a minute. 2 equals 10. So 2x plus 3 over x plus 5 equals 10. I'm going to subtract 5 from both sides. 2x plus 3 over x equals 5. Now the next step is I need to put these x's together. But what's really cool is that we have a denominator. And what happens if I multiply both sides by the denominator? So I'm going to do the distributive property to everything. So we're going to have 2x squared. Now I'm just going to rewrite this one. And then we're going to simplify it here in a second. Equals 5x. This gives us 2x squared. Now the x's are going to cancel, which is super nice. Equals 5x. I have a quadratic equation here. So to solve it, I need to make it equal to 0. So we're going to have 2x squared. I'm just going to rewrite the original here. Plus 3 equals 5x. I'm going to subtract 5x from both sides. Now we have 2x squared minus 5x plus 3 equals 0. Oh my gosh, we are going to try to factor this. It's actually going to be the grouping method because I have a number here other than 1. Sometimes a grouping method is called the AC method, but we need to think of numbers that multiply to 2 times 3, which is 6, but also add to negative 5. Well, we kind of have it here. Negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. Doing the grouping method, we're just going to rewrite this 2x squared. Now instead of negative 5x, we're going to write minus 2x minus 3x. And then this comes down, plus 3 equals 0. Grouping methods means we're going to put the first two together and the second two together. The first two, I need to find the common factor. So I'm going to go over here to the right. 2x squared is 2 times x. And then negative 2x is 2 times x times negative 1. Now I know a lot of you probably saw that 2x was my greatest common factor, but some of us don't see that right away. So it's a really good idea to do this on the side. We're going to write 2x and a parentheses. Now I divide each piece by 2x. 2x squared divided by 2x is x. Negative 2x divided by 2x is negative 1. Now we're going to do the same thing for the other side. We have, let me move this up just a little, all right. Negative 3x equals negative 1 times 3 times x. And 3 is 3. Now I think I've mentioned in other videos that Anytime we have a negative here, we're going to for sure take out a negative number. So even though our greatest common factor is 3, because of this right here, we're going to actually take out a negative 3. I'm going to write negative 3 parentheses, and now I'm going to divide each piece by negative 3. We have negative 3x divided by negative 3 is x. 3 divided by negative 3 is negative 1, and it equals 0. I want to point out that if we hadn't taken out negative 3, let's say we took out a positive 3. Well, negative 3x divided by positive 3 is negative x. 3 divided by 3 is 1, and we'll have a problem because these don't match. And so if you ever run into that, look back and say, oh, wait a second, I should have taken out a negative. But we are on the right track. Let's rewrite it. We're going to have x minus 1 times, if I take out x minus 1, I'm left with 2x. If I take out x minus 1, I'm left with minus 3 equals 0. We're almost there. Now we're going to make everything that has a variable equal to 0. X minus 1 equals 0, and 2x minus 3 equals 0. I'm going to add 1 to both sides, so x equals 1. I'm going to add 3 to both sides, so 2x equals 3. I'm going to divide by 2, so x equals 3 halves. Okay, well, we have our x's, that's for sure. Let's go back up and review for a second. We have our x's, but we still need our y's. So let's go back up here and review for a second. We know that x times y is 3, so I'm going to rewrite that here. I'm going to make a little box here. X times y is 3. Well, we just figured out that x equals 1 and x equals 3 halves. So for the first one, if I put 1 in for x, it turns out that y is 3. Let's do the second solution, x, y equals 3. I'm going to put 3 halves in for x. I can divide by 3 halves, or since we're doing it by hand, we're just going to multiply by its reciprocal, 2/3. Now we have y equals, the 3's cancel, 2. Now what did we actually figure out? Well, when 1 is x, 3 is y. And when x is 3 halves, y is 2. And of course, we can check that. We'll do the first one. X is 1, so put 1 in for x. And y is 3, so 3 plus 2. That should equal 10. Well, 2 times 5 is definitely 10, so that works. Let's try the next one. Well, we have a fraction, but that's okay. We'll have 3 halves plus 1 times y, which is 2. 2 plus 2. Let's keep doing this by hand. So 3 halves plus 2 over 2 times 4. I'm running out of room here. I have to erase a little bit here, but that's okay. Now we have 5 over 2 times 4. Now that is the same thing as saying 5 halves times 4 over 1. These will cancel, and guess what? We end up with 10. That means that these are both of our solutions. Now, how awesome is that?